Next up in our study of the forms of linear equations is point-slope form, which we're going to see is really just kind of a cousin of slope-intercept that we've already learned. So just to recall, point-slope form is y minus y1 equals m times the quantity x minus x1, and m is still the slope, and x1 comma y1 is any point on the line that you're given. Okay, remember there's an infinite number of points on any line, and any one of those is going to give you the same equation. Okay. Of course, I want you to note the difference between x and x1 and y1. xy, the coordinates xy, and this is this y and this x, you need those in the equation. Just like in y equals mx plus b, you have an m and you have a b, but you always have the variable x and the y in the equation, and you want them there. Okay, so note that xy are any points on the line. You need x and y for the equation. The given point that you start with is the x1, y1. Okay, and that could be any starting point. Obviously, if you have different numbers in here for x1 and y1, the equation will look different, but because it's all describing the same line, when you convert it to slope-intercept, which we're going to do in just a second, you'll see that no matter what you start out with, you're going to end up with the same line. Okay? So think about the connection to slope-intercept. Okay? Suppose you were given a starting point of 0, 3. So 0, 3, 0 is on the x-axis, 3 is on the y-axis. So if you sketch this out, the point 0, 3 is like right there, right? It's on the y-axis. Well, then you have the y-intercept. If 0, 3 is where it's crossing. It's where it's crossing the y-axis. So by being given a point like this, 0, 3, you actually have the y-intercept, which is 3, which is b. Okay? Then the point-slope form of the equation is y minus 3 equals m times the quantity x minus 0, which simplifies to y minus 3 equals mx. Or, in other words, y equals mx plus 3, which, as you can see, this is now in slope-intercept form. We've solved for y. We started out with this big messy thing, and we said, okay, well, if we have y minus 3 equals m times x minus 0, and we knew that because we had the point 0, 3, 0, 3 right there, and again, this was the x, and that was the y. So we just plug that in and we get that point. We already knew we had that point, so when we actually solve it for y, it turns out that we have the slope-intercept form. Okay? And notice that the slope doesn't matter here. I started out with a slope of m, any slope, and I still have it. So it doesn't matter what slope you're talking about. And I've actually written that on the next page here. So regardless of the slope or the starting point, any point-slope form equation can be solved for y, or in other words, it can be converted to slope-intercept form. And the same goes for standard form, which we will look at next time. We're not doing standard form right now, but you can do the exact same argument for standard form. So, example time. We've got a couple of examples here. Let me zoom in just to make it really obvious what we're doing. Okay. So, the directions say write the point-slope form of the equation of the line described, and then I've added and convert it to slope-intercept form. So, if we look at this, okay, we're looking at through 4, 2, so this is our starting point, and parallel to this line here. Well, if it's parallel to this line, then I know that that has to be my m, because this is y equals, so this is mx plus b. So if that's mx plus b, I know it has to be parallel to a line with a slope of -3/4. And if it's parallel to a line of slope of negative 3/4, then the line I'm looking for also has a slope of negative 3/4 because they have to have the same slope if they're parallel. So if we look at the way our equation is going to be set up here, okay, so again we have y minus y1 equals m times x minus x1, and so it has to go through this point. So there's my y1 and my x1, and there's my m right there. So I just go through the motions here. So y minus 2 equals negative 3/4 times x minus 4. Okay? So my y1 became a 2, and my x1 became a 4. And so now all I have to do is, this is the point slope form, so now I just have to convert it to slope-intercept. So I need to get the 2 over here, and I need to distribute this negative 3/4. So I'm just going to distribute first. So negative 3/4 x, and here the 4 will cancel with the 4 because it's 4 over 1. I'll be left with 3. Negative times negative is positive. So I have that. And over here I'm not doing anything. So now if I add 2 to both sides, okay, I'm getting those go away, and I'm getting y equals negative 3/4 plus 5. And so that equation is the same line as what we started with, or rather, excuse me, what we started with right there. Okay? So these are the same line, and if we were to graph them, it would be the exact same line. Both of them describe the same thing. Notice here I have this format. I have this point slope format where I have a slope and then I have this point embedded in here, and the point is embedded in here, there, excuse me, and there. Okay, so I have the point embedded, but just like there are an infinite number of points on the line, I can have an infinite number of combinations of those two things. So this 2 and 4 are not unique. So I could have any number of points in there that are on that line. And if you just think about it for a second, like if I have some line, you know, like going like this across my axes, I have a point there, and 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 there's a million other ones, but they're all on the same line. So the line is the same, so the equation has to be the same everywhere, the equation for the line. So if I have different starting points, x and y, that means I may just be picking, you know, that point as opposed to that point. But it doesn't matter which one I pick because I'm going to get the same equation out of it. So even if you're starting with a different point value here for y1 and x1, you're still going to end up with this same slope-intercept form. This is one of the many reasons that slope-intercept form is so useful, because this slope-intercept form of this line, that's the only slope-intercept form of this line. This is the only one. And in point slope, you could have many different ones in point slope. So you can have only one slope-intercept and many different point slopes, because there's each time you put a different point in, you're going to get a different equation in that format. But if you go through the steps and convert it, they will all, even though they're starting out in different places, they will all convert to the same slope-intercept. So let's look at another example here. Through the point -3, -3, parallel to this thing, and this thing has a slope of 7/3, so I know it's going to be the same, the same slope as that one. So y minus y1 equals m times x minus x1 becomes what? Well, it becomes y minus a -3 equals m times x minus a -3. Of course, my double negative, I'm writing this out so that you just see it, but normally I would not even do that. I would just switch it automatically to y plus 3 equals m times x plus 3. And then, of course, I'm just distributing. Oh my gosh, wait a minute. I left out my m. I know what my m is. What is m? m is that. M has to be the same as this m, so we know it has to be 7/3, and so that has to be 7/3. So now when I'm distributing, okay, I get 7/3 x, and the 3 cancels with the 3, and I'm just left with 7. So then when I subtract 3, I'm going to have 7/3 x plus 4. And so there is my slope-intercept for the same equation, or excuse me, for the same line. So here we're going through 2O, and it's parallel to this line with a slope of 1/3. So I would be at y minus 0. Notice this is not the y-intercept, it's the x-intercept. So y minus 0 equal to 1/3 x minus 2. Alright, so this is easy here. I don't have anything over here, so this is already in prime position to just be done. Right, I distribute the third and I get third x and minus 2/3. So there's my slope-intercept, and again here the slope is 1/3, as I knew it would have to be, and the y-intercept is minus 2/3. So really, if you know what the slope of the line it's parallel to, you know what the slope of the new line is going to be. So really the only thing you're gaining here by doing all of the math in these problems is you're gaining the y-intercept. Because if you know it's parallel to something that has a slope of 7/3, then you know that the line that you want has a slope of 7/3. So the slope isn't really the benefit of the SI form, because you already have the slope, but you're finding the intercepts. That is the benefit of converting this. Like in here, we already know this is going to have a slope of -1 because it's parallel to a line that has a slope of -1, and that's the negative on the x is a -1x. So we already know that the slope, converting this to slope-intercept, the slope's already a given. It has to be -1. So we're interested in really figuring out what the intercept is. So y, I'm just going to go ahead and convert these straight to positives here because it's a -4 for the y. So that's a y plus 4 equals -1 times x minus 4. Notice that the x is a minus 4 because in the actual format for the form in the actual equation here, these are already negative signs. So when I plug in a negative y, it becomes y minus that negative or y plus. And here, since the x is positive, I'm just doing x minus that positive number, which is just the subtraction. So whenever you're distributing by a negative sign here, and I'm putting this -1 just to show you that it's the -1 right there, but really nobody would write that. We would just write the negative sign. It's the negative of everything inside. So if I'm flipping all the signs in here, then this positive x is going to become a negative x, and this -4 is going to become a positive 4. And now I have that, and so if I want to subtract a 4 out here, I'm going to get a negative y equals -x. And so I need to really think about, okay, well, what does that mean? What does that mean? Believe it or not, it's in slope-intercept form, because y equals mx plus b reveals that the m is the coefficient on the x, so it is -1, which we knew it would be because it had to have that slope. And we also know that the b is what? What is the b here? Well, if it's -x, then it's -1x plus 0. So the b is 0. This is actually crossing. Let's think about what the b of 0 means. If b of 0, this is x and this is y, so if the b of 0 means that that 0 is the y-intercept, right? So 0 on the y is the y-intercept, so it's just crossing here at the origin. And it could be going like that, or like this, or like whatever. But we know that the slope is -1, so we know it's going to be a negative slope like that, right? A nice negative coming down the hill.